Hello and welcome back to Python 101. My name is Michael Driscoll, and today I will be teaching you about exception handling in Python. What to do when things go wrong. In this tutorial, we'll learn about why you might need exception handling. So you might need exception handling when you accept user input. You never know what your users will do. They might type characters in that you don't expect. For example, you might have a dialog that asks for integers, and your user might completely ignore you and start typing numbers in or special characters. Another time you might need exception handling is when you accept files from users. So, you might have a client and you say, I accept XML, but they give you a JSON file. You just need to find a way to raise an exception or to handle that gracefully and let the user know that they gave you the wrong file type. You might have to need exception handling for working with APIs. This is usually because the API is external to your program. So if you go to query it and your internet isn't up, you might have an exception happen and you need to figure out, do you want your application to crash, or do you want it to do something much more nice like display an error to the user, letting them know that they should probably turn on their internet or investigate why it's not working. When you work with databases is another time when you need exception handling. Often a database can cause you oddball problems. For example, you might hit the database when it's really, really busy and your application might time out. Or the database might be down, or the internet might be down, or the internal network might be down. There's all kinds of different reasons that can cause exceptions to happen, including exceptions within the database itself, where the database just fails for some reason. Other times you might need exception handling or when you work with other processes. So in Python, you can call another process using subprocess. And sometimes that process doesn't work the way you expect, or the process doesn't exist on a brand new computer and you didn't realize that when you ran the program. And so you just end up with funny looking errors and your program doesn't work the way you want. Probably one of the most common ones is when you read and write files though. So let's say I try to open a file that doesn't exist. You're going to get an exception. Or let's try to write a file to a place that I don't have permission to write the file to. This happens often in Windows. So if I wanted to write to like the Windows folder or the program files folder on Windows, it's probably going to give me a permission denied error and my program will fail. So what will you learn in this tutorial? Well, I'm going to teach you about the common exceptions in Python, how to handle exceptions, how to raise an exception after it's been handled. We'll also look at examining exception objects, using the finally statement, and using the else statement, which we'll get to near the end. Okay, let's talk about some of the common exceptions that you'll see when using Python. So exception is one of them. The exception is your base exception that all of the other ones are based on. So eventually I'll teach you all about classes in a future video, but each of these is basically a class and all the other ones are based on exception. Like I said, I'll teach you more about that later, but that's basically what you need to know. The attribute error gets some of its attributes from the exception class. So an attribute error is raised when an attribute reference or assignment fails. So that happens when you try to access like an attribute that doesn't exist in an object. Like say you're using a string and you try to do like string.number or something. It's going to raise an attribute error because strings don't have a number attribute. An import error is raised when an import statement fails to find the module definition, or when a from.import fails to find the name that is to be imported. So what that means is, you try to import something that doesn't make any sense, like import monitor, or import something that doesn't, some other module that doesn't exist in a standard library or something that you haven't created. You'll get an import error. I'll actually show you what this means exactly. Module not found error is a subclass of import error and is one that you'll see much more commonly in Python 3. In Python 2, you saw import error all the time. I think nowadays in Python 3, you'll most likely just see module not found instead of the import error. Index error is raised when a sequence subscript is out of range. What that means is if you try to access an item that isn't in like a list. So if you have a list that has 5 items and you try to access the 6th item or the 10th item. You've tried to access an item that doesn't exist, so you'll get an index error. The key error is related to Python dictionaries, and it is raised when you try to access a key that is not in the dictionary. Keyboard interrupt. I actually don't see this one that often, but if you hit Control-C when your user is using your program, it can cause the keyboard interrupt exception to occur, and that's when you'll see it. The name error is raised when a local or global name is not found. What that means is if you try to access a variable that you haven't defined yet, you'll get a name error. OS error, raised when a function returns a system-related error. You'll see this fairly often when you're like trying to write files or access things you're not supposed to. You'll see OS errors. I saw this a lot in Python 2 more than Python 3, but you get system-related errors. You also get an I/O error if you try to write something that you're not allowed to. And we have a couple more to look at. Runtime error, raised when the error is detected that doesn't fall in any of the other categories. This one I usually raise myself, but you'll occasionally get it from when you're running a Python program. Syntax error is probably one of the most common ones. It's raised when the Python parser encounters a syntax error. So, you typed something incorrectly, or you opened a parenthesis and you didn't close it, or you didn't add a colon to the end of a conditional statement. You'll probably get a syntax error. Finally, you have the type error, which is raised when an operation or function is applied to an object of inappropriate type. The associated value is a string giving details about the type mismatch. So you might get that when you try to work on a function in a way that doesn't make sense. Like you try to use a string and an int and put them together, you might get a type error. Finally, you have the value error, which is raised when a built-in operation or function receives an argument that has the right type but an inappropriate value. And the situation is not described by a more precise exception, such as an index error. And finally, we have the zero division error, which happens if you divide any number by 0, it gets raised. For a full listing of all the built-in exceptions, you can go to the Python documentation here at this link. All right, let's talk about handling an exception. So when you want to handle an exception, you capture it in a try except statement. Let's see how this works. Here's the basic form. You type try, put some code in there, except, and then the error that you expect to catch. So in this case, I'm expecting to catch an import error. Let's go ahead and try to do this. Well, I should try to do a couple of these different ones. So let's do try, and we will catch like 1 divided by 0. So let's try to catch that with a let's see, except. Let's try to catch that with an I/O error. Print I caught an I/O error. Yay. All right, let's run this. So this didn't catch it because it didn't print out I got an I/O error. Instead, we got the zero division error raised. So that gives me a hint that I did something wrong. So let's put this zero division error in here instead and then try to rerun this code. So now when I rerun it, you can see that it's printing out my string. But now I see I've got another problem. I'm saying I found an I/O error when I actually have a zero division error. So you can fix that and rerun it. And now you're catching the zero division error. Now what this should probably say is something like you cannot divide by 0. That's probably what it should say. You need to make sure that the message that you print to the user actually makes sense. In this case, you're telling the user, hey, don't do that. You can't divide by 0. Now, we could try doing some other things, like let's say we have A equals 2, and then we try to print B, and we try to catch that. I don't think this is going to work because B doesn't exist. Yeah, so we get the name error here. Name B is not defined. Now we could catch this But in this case, I don't really want to catch that because, I made a mistake. And B should really be defined here. Anyway, this is the basics of how you would catch an exception and how you would handle it. You do the handling in the except, and here you tell the user what they need to do, and then you can exit your program here using sys.exit. You could pop up a dialog and let the user know what's going on and tell them to re-enter a new value. If they were, trying to divide by 0, tell them to divide by something else. This is where you do it in the except statement. Let's move on. When you write the except without specifying the exception type, it is called a bare exception. These are not recommended. So here I am opening a file, and then I have a bare except. So when an error occurs, I don't really know what kind of error it is. So let's go back to this one and just change this to a bare except. And when I run this, it just says you cannot divide by 0, which, doesn't make any sense because you look at this code and you're like, what? I'm not dividing by 0. What's going on here? Because I'm not showing you what's happening, I'm not actually specifying what exception type I'm catching. Except just catches all of the exceptions. So that's why it's called a bare except. And it can be really confusing trying to debug what's going on. In fact, sometimes it's better just to get rid of the bare except entirely and just run the code to figure out what's wrong. And now I know it's a name error. Depending on what kind of code you're working with, that may or may not be the thing that you want to do. But that's one quick and dirty way to figure out what's going on. All right, let's talk about catching multiple exceptions. So here you can do multiple excepts. Here I want to catch an OS error and an import error. So when I run this, I'm going to catch an error that might have happened when I'm working with the file, or it'll catch an import error. If I were to run this code, it's going to catch an import error because something isn't a valid module name. If another type of exception occurs, though, this handler won't catch it and your code will stop. So if I had something like 1 divided by 0 here, like as the last line in this try except, the code would fail and this try except wouldn't catch it because I don't specify the 0 divide by 0 error here. The other thing you could do is to add a bare except on the very end to catch any other unexpected errors. Again, you won't know exactly what exception happened, but you'll still be catching it. Another way to rewrite this code to look a little bit simpler is that you can use parentheses and commas to put multiple exceptions on the same line. So here I have exception OS error and import error, basically, and then I can print an error occurred. The problem with doing this is that now when an error does occur, I don't know if it's an OS error or an import error. Which one actually happened? I'm not telling you right here. So again, I usually recommend putting the exceptions into separate except statements so that you can tell what's going on with your code. All right, let's move on to raising exceptions. This is a lot of text. I'll go through it for you. So, what do you do when you catch an exception? You have a couple of different options. You can print out a message. You could log the message to a log file for later debugging. Or if the exception is one that you know needs to stop the execution of your application, you could re-raise the exception, possibly adding more information to it. Raising an exception is the process of forcing an exception to occur. You raise exceptions in special cases. For example, if a file you need to access isn't found on the computer, you might raise an exception. So, in Python, it has a built-in raise statement to raise an exception. So here you type try raise import error, and it'll catch it. So, let's see. When you raise an exception, you can have it print out a custom message. So raise exception, something bad has happened. You'll get this traceback, and it will say something bad has happened, or something bad happened in this case. So when you do raise, you can pass in whatever string you want to give it a descriptive exception message. If you don't provide a message, then the exception would look like this. So in this case, I just raise exception. It says built-in exception, no message. So let's take some time and examine the exception object, because as you know, everything in Python is an object. When an exception occurs, Python will create an exception object. You can examine the exception object by assigning it to a variable using the as statement. So here we have except import error as error. That lets me examine this error object, or exception object. So if we print out the type of the error, we find out it's an import error. We can print out the arguments, bad import, and then we can print the error message itself, bad import. So this is the error message. Args refers to the string that we passed to it here. And that lets you examine what's going on. And you could use this example back when I had those multiple exceptions on one line, where you had import error and OS error. If you do as error at the end, then you can examine it and figure out which error actually happened. I still think it's simpler to put the errors on separate excepts, but this is one way that you could examine and use Python's introspection to figure out what's going on. All right. In this example, you assigned import error to the error variable. Now you can use Python's type function to learn what kind of exception it is. And then you can solve the issue you mentioned earlier, which I just talked about. All right. Using the finally statement. The finally statement is a block of code that will always run even if there's an exception raised inside of the try portion of the try except. You can use the finally statement for cleanup. For example, you might need to close a database connection or a file handle before you close your program. To do that, you can wrap the code in a try except finally statement. So here is a rather contrived example. 1 divided by 0, except 0 division error. It'll print out this message, and then finally it'll clean it up. So run that, you get that code. Let's try something else. Let's say just try that A and B thing again. So this time we'll do print B. We'll catch our value error. Actually, let's not catch it at all. So now if we run this, it'll go B is not defined. I think because I'm running this in Jupyter, it's not doing exactly what I want it to do. Oh yeah, it is. Cleaning up. So it still did the cleanup, but it also printed out the exception, which is fine because it's still cleaned up. So anytime an exception happens inside the try part of your try except, the finally statement will still run, but you'll still get the exception object out, or you'll still get the exception printed out, I mean. You can skip the except statement entirely, which is what I just did in the previous example, and create a try finally instead. So this is a try finally statement. When you run it, it still says cleaning up, and it still catches, it doesn't catch the 0 division error, it just cleans up after it. So this time you don't handle the 0 division error, but the finally statement code runs anyway. We have one more statement to look at, the else statement. There is one other statement, and it's the else statement. You can use the else statement to execute code when there are no exceptions. Here's an example. Try to print this try block, except an IO error, else, print, this is the else block. So in this code, there was no exception. There wasn't an IO exception here, so it's going to print this line here, which it does. And then it falls to the else statement because no exceptions occurred, and so it prints what is inside the else statement. Let's try raising an IO error and see what happens. So here I raise the IO error, and because I raised it, it's not going to print anything because it drops to the exception handler. So now the exception handler runs and prints an IO error has occurred. But that's all it's going to print. It won't print this line because we raised an error, and it won't print this line because the else statement is getting skipped because an error occurred. Since an exception was raised, only the try and except blocks ran. Note that the try block stopped running at the raise statement, never reached the print function, which is what I was just talking about. Once an exception is raised, all the following code is skipped over and you go straight to the exception handling code. All right, so let's wrap this up. Now you know the basics of Python's built-in exception handling. In this tutorial, you learned about the following topics. You learned about common exceptions, how to handle exceptions, how to raise exceptions, examining the exception objects themselves, and then you learned how to use the finally statement and the else statement in your try except. At this point, you know how to harden your code a little bit using Python's try except. You can give messages to the user to tell them what's going on, and you can prevent your application from just crashing. Use this knowledge wisely, and if you have any questions, feel free to drop them in the comments below. Thanks so much for being here and listening to me talk again about Python. I'll see you next time.